Good morning all. Here we have a bad DC to DC converter removed from a Siemens ADI4 module. Model number 6FC521-0BA01-0AA2. The part number on this bad DC to DC converter is UM1507-02, manufactured by Universal Electronics. I'm going to apply 24 volts DC to the input side, and we're going to look at the output side with our Fluke DMM set to voltmeter. Here are the pins on the input side and the output side. Let's put plus 24 volts DC and ground on the input pins. And we are going to connect to the common and 5 volts to begin with. Let's see what we have when we apply 24 volts DC to the input. We have about 140 millivolts DC. That is bad. Let's go look at the plus and minus 15. That's low. We only have 11.2 volts DC on the plus 15 volt side. Get my close-up glasses on so I can see. And here's the minus 15. It is also low at minus 11.3 volts DC. Now we're going to take a look at the part that I installed as a replacement for this DC to DC converter. And that's it right here, and its part number is EC5C08, manufactured by Syncon. Same exact pinouts, plus 24 volt DC in, common 5 volts, and plus and minus 15. This dropped right in, although the package is a little bit larger. The pinouts were identically spaced, and voltage wise they were pinned exactly as the old part. Let me turn the 24 volts off here. Undo our Fluke DMM and our 24 volt DC power supply. Here's ground of the 24 volt DC power supply and positive of the 24 volt DC power supply. Let's connect our meter to common and plus 5 volt pins, and let's see what we get with the good DC to DC converter. There we go, that's what we should have, plus 5.065 volts DC on the 5 volt terminal. Let's look at the plus 15. On the plus 15 volt terminal, we have 15.19 volts DC on the plus 15 volt lead. Let's go to minus 15. And there we have minus 15.64 volts DC on the minus 15 volt lead right there. This is a good one. Now let's go back to the bad one, and we'll put the Fluke Oscilloscope at the output to replace our Fluke DMM set to volt meter. Can we get in there? Looks like we can. There's 2 volts per division. Let's hook our leads up to the DC to DC converter, applying 24 volts DC to the input. And look, it's starting up and shutting down. Can you all see that? So now I've got it set to 1 volts per division. We're going up to about 2.2 volts DC and then shutting back down. Up to 2.2 volts DC and shutting back down. Let's see what the plus 15 volt circuit looks like. I've got 10 volts per division out here. Oh, look at that. We have some sawtooth action up on the positive half of this DC to DC converter output. But that should be a smooth 15 volts DC right there. There's 5 volts per division. Let's look at the negative 15 volt DC output. We have the same waveform, but on the negative side. Whenever I see a DC to DC converter in one of the units that I'm working on, I zoom right into that, because 50% of the time the DC to DC converter is the failure of the unit that I'm working on. Not all the time, but a good proportion of the time. And it never hurts to look at it anyways while you're troubleshooting. All right, all. Thank you very much for stopping by and watch us test a bad DC to DC converter and a good DC to DC converter. I hope y'all's having a good day out there. Be careful. You never know when things are going to fall apart. Always kind of good to be prepared if you can. Have a good day. Enjoy your time on this side of the dirt. And we'll see you next time.